This is the recorded lesson for Wednesday, August 26th. So today we're just going to be covering these slides numbers 3 through 45. The only assignment that you have for today is to complete the scientific method notes in your science notebook. I'm going to give the information first, and then at the very end, you will be able to copy down your notes. So you're going to listen to me talk, and then at the end of the slides, it will have your options for copying down the notes. So today we're going to go over our first unit on the scientific method. Make sure you are adding the scientific method to your table of contents for page 2. And that you're also setting up that notes page right after our notes that we took on Tuesday for drawing a scientist. It's going to be right after that. You're going to have the title, scientific method, on the very top, the date in the top right-hand corner, and page 2 in the bottom right-hand corner, just like my picture. So the scientific method is a process of steps that scientists use to conduct experiments. It's kind of like the rules of conducting an experiment, if you want to call it that. The scientific method is used by scientists all around the world. It helps make sure that the results of an experiment are correct because it has your laid out steps. If you think of the scientific method kind of as a recipe, if you're making a cake, that recipe has the set steps on what you do and how you do it to make that cake, to make sure that it turns out as an edible cake at the end. The scientific method is the steps that scientists use to make sure that their experiments are done correctly and the results are done correctly as well. It also helps make sure that the scientist does not interfere with the experiment, that they don't do something just to have the experiment come out with the results that they wanted it to come out with. The scientific method has 6 steps in total. The first step is to ask a question. Usually the question develops from curiosity about something that happens in the world. For example, there was that big discovery with gravity where the apple fell out of the tree and the person wondered why that apple fell from the tree. You want to make sure that you have a testable question, though. A testable question is a question that is not answered by a simple yes or no, like, do you like dogs? Not a good testable question. Your question also needs to make sure it allows us to collect data. So, for example, if I ask, do you like dogs or cats better? That's not really a good question to do an experiment on because it's not allowing us to collect too much data. And finally, your question, you don't want to have a question that asks how to perform a skill, like how do you make a cake? How do you throw a ball? You don't want to do this because there's usually just one set way to make a cake or throw a ball, and your question that you want to conduct an experiment on needs to be larger than that. So, some examples. Do you like plants? That would not be a good testable question because it is answered with a simple yes or no. Next one, do you like flowers or trees better? That would not be a good testable question because it's not really allowing us to collect any data. The only 2 options are flowers or trees. Next one, how do you plant a tree? Not really a good testable question either because it's asking about how do you conduct a skill? How do you plant a tree? Not something you can usually make a experiment out of. Last one, why is my plant dying? This is actually a great question to conduct an experiment on. It's not answered by a simple yes or no. It's going to allow us to collect different forms of data, and it's not asking about a specific skill. The second step of the scientific method is to gather information. This step is pretty simple. You just want to simply learn more about the topic of your question. For example, if I ask the question, why is my plant dying? I would read some information about my plant or maybe ask a gardener about my plant. This information that you learn is going to be used in the next step and the step after that, especially when it comes to designing your experiment. The third step is to form a hypothesis. The hypothesis is just a really fancy word for a simple thing. Hypothesis means it's a possible explanation or educated guess. Usually a hypothesis is in the same form, if, then, and because. For example, the information that you read about your plant, if you find out that plants don't like direct sunlight or too much sunlight, and your plant has been sitting in front of a window, your hypothesis or your educated guess for why it's dying, your question, could be, if my plant receives too much sunlight, then it will die because it does not need a lot of direct sunlight. See how it used the if, then, and because format? And it gave a reasonable explanation for your hypothesis. For your question. These are some things that you can just look at to help you with more understanding and to help you practice forming a hypothesis. The fourth step of the scientific method is to test your hypothesis with an experiment. Two important rules of an experiment are that you test only one variable at a time. This means that there's only one change in your experiment. Two, you always want to run a control for comparison. You want to have something to compare your tested subject in. So, for example, if I am trying to test or have an experiment on my question, why is my plant dying, I can get two plants exactly like my dying plant. I can place one in the direct sunlight and the other in a shaded area. With doing that, I want to make sure that I'm only changing one thing. The change that I would be having in my experiment was the amount of sunlight that the plants were getting. That's why one would be put in front of a window and one would be put in a closet or in the shade. All the other variables, such as how much water the plant gets, the temperature of the area it's in, and the soil that I use, are kept the same so that I only have that one change, the sunlight. Independent and dependent variables are the things that you are doing in your experiment. For example, the change in your experiment is going to be your independent variable. The dependent variables are going to be the things that you're measuring, the things that you're looking at. My independent variable in my plant experiment would be the amount of sunlight. That's the only factor I'm changing. My dependent variable could be the growth of my plant. I want to measure the growth to see if it's dying or living, and that growth is dependent on how much sunlight it gets. My control is going to be the plant in the shade. That's the comparison that I have. And the things that I have as constants, or the things that I stay the same, are going to be the water, the temperature, and the soil that I'm using in that experiment also. The fifth step is to analyze your data. That also includes recording any observations and data that you may have, to graph your data, and when you're looking at the data, to look at any patterns or unexpected results. You want to maybe try to start forming some conclusions about what your experiment is showing you. Data is collected facts and figures, and I bet you didn't know that data is not just numbers. Qualitative data is data that's in words. This includes observations, and you'll see an example of that in a minute. And quantitative data is in numbers. So, for example, quantitative data would be things like your measurements, whether it's in length, weight, time. Those are numbers, so that's quantitative data. Qualitative data would be more relying on your senses, vision, hearing, smell, taste, and there's a kind of a cool activity if you click the picture that you can do. You don't have to, it's just something to look at how you're collecting qualitative data. So here is an example of some of the data that I might get from my plant experiment. So I have my two different types of plants, the one I put in the sunlight, the one I put in the shade. For the sunlight, I wrote down that it was healthy, then it started to wilt a little bit, then the plant started looking a little yellow, and by day 10, my plant in the sunlight was dead. For my plant that was in the shade, I wrote down that it remained healthy all the way up until day 10. So think about, what does this data show? What can I maybe conclude from this data? Also, is this data qualitative or quantitative? Is it in words or is it in numbers? This data shows that sunlight may be killing the plant because all the other variables, those things that I kept the same, like how much water the plant was getting, were kept the same. So the only change that I had was that sunlight. So that must be the reason it's killing the plant. This data is qualitative because it's using observations and it's putting it into words. The final step of the scientific method is going to be to form your conclusions. You need to determine whether your hypothesis was supported by the data or not. So in my case, if I did conclude that the sunlight was what was killing my plant, my hypothesis would be correct. And also make sure that you run your experiment a couple times and it has the same results. That way you also know that your results are correct. So from, again, my example experiment with my plants, I could conclude that too much sunlight killed my original plant. This is a game that you can play by yourself just to check yourself. If you click the answer choices A, B, C, or D, and it is incorrect, it will say, oh man, it will show you that it's incorrect. If you hit the heart, it will take you back to the question. Once you finally get that correct answer, it will tell you, click the heart again, and it will take you to the next question, and you just continue. So you can absolutely go through those questions and find the answers on your own. I'm going to fast forward to the very last slide. After you're finished going over those few questions, this is the time that you would take your notes on the scientific method. So you have two options to take your notes from. You may click this link and it will take you to a picture of the notes. And the blue lines are just supposed to be lines in your notebook so you know when to skip a line and that kind of stuff. Or you have the option of watching me do a video of the notes and read them aloud to you. With this video, throughout the notes, you will have to pause it in order for you to have time to copy the notes that you see on the screen with the video.